Section 6.6 is on systems of inequalities. A system of inequalities is two or more inequalities with the same variables. It's very similar to a system of equations, but instead of having equal signs, we're going to have, remember, greater than, or greater than or equal to, or less than or equal to signs. And I believe it was back in chapter 5, maybe it was chapter 4, we graphed just one linear inequality. So what we need to do now is graph both of these and see where they overlap each other. So if you'll recall, it should be written in y equals mx plus b form to make it easier to graph, okay? And if it is a less than or a greater than, it's going to be a dashed line. If it's a less than or equal to or a greater than or equal to, it's going to be a solid line. If it's written in y equals mx plus b form, if it's less than, we shade below the line. If it's a greater than, we shade above the line. So to do this, I like to do them in two different colors. So I'm going to start with this first one here and I'll label that pink. So I have y is greater than negative 2x plus 1. So for this one, it's going to be dashed. And since it's a greater than, I'm going to shade above the line. So let's graph that. So begin with your y-intercept, your b of 1. My slope is negative 2, which means down 2 and right 1. And I'm going to keep doing down 2 and right 1, or up 2 and left 1. And this line is dashed, so I'm going to throw in my little dashes here. Okay, and when you're doing these on graph paper, you can kind of lightly shade. I would lightly shade this area here up above. Because I'm doing it in color, it's going to be a little hard to see. Actually, maybe I'll try it. I'll go ahead and shade. So this is the part that I would shade right here, because that's where the y-axis is above this line. Let me do my second one, my second inequality in blue. And this is a less than or equal to, so this one's going to be solid because it's that or equal to. And since it's a less than, it's going to be below. So let's start at 3 on the y-axis. And my slope is 1, so that means up 1 and right 1. Or down 1 and left 1. And even though I'm making all of these dots, it really is not important the exact point where these two lines intersect each other. I'm just looking for the shaded areas. Okay, so this is a solid line, so let's connect all those dots. And for this one, I'm going to shade below the line. Where is the y-axis? Below the line, and that would be all of this area here. Now what I'm looking for is where do my two shadings overlap each other. So I shaded above the pink line and below the blue line. So the area of overlap is all of this region right in here. So I'm going to go back and shade that in nice and dark so it really stands out. And that's my solution. There is nothing to box. Your solution is the graph. What does this mean? This means that every point in this dark shaded in region right here works in both of those inequalities. So there's an infinite number of points that work, and they're represented by this shaded area right here. Let's take a look at another example. Here I have 2x plus y is greater than or equal to 2, and 2x plus y is less than 4. In order to make this easier to graph, I need to write these in slope-intercept form. So this equation, subtracting 2x from both sides, is going to give me y is greater than or equal to 2x plus 2. And this one, subtracting 2x from both sides, is going to give me y is less than negative 2x plus 4. And right away I can see that the slopes of these two lines are the same. And you'll recall from chapter 4 that if the slopes of two lines are the same, that means they're parallel. So let's see what happens when we actually draw these and start shading. So my first one is, since it's a greater than or equal to, it's going to be solid. And it's a greater than, so I'm going to shade above the line. So starting at 2 on the y-axis, and my slope is negative 2, so down 2 and right 1, or up 2 and left 1. And this is a solid line, so let's connect those dots. And for this one, I will be shading above the line. So that's going to be everything over here. Okay, my second line I'll do in blue. Y is less than negative 2x plus 4. So since it's just a less than, it's going to be dashed. And a less than means it's going to be shaded below. So in this case, my y-intercept is 4. And again, my slope is negative 2. So it's going to be, as you can see, it's ending up being a parallel line here. Down 2 and right 1, or up 2 and left 1. This one is dashed, so I'll add a few little dashes in between there. Okay, and I'm going to be shading below this line, so that's going to be everything over on this side of the line, because that's where the y-axis is below. Now, it's a little hard to see here, but let's think about what our solution is going to look like so we can shade it in nice and dark. So I'm above, or kind of to the right and up, kind of in the northeastern direction of the pink line, and then I'm going down and kind of to the left on the blue line. Where did those overlap? It's this area right here in between the two lines. So you need to make sure that you shade that in nice and dark between the two lines. Okay, so that's my solution. Any point that is in that region is going to work in both of these inequalities. Let's take a look at our third example here. These are already written in slope-intercept form, so that's good. So I have the line y is greater than or equal to negative 4. So this is going to be solid, and it's going to be above. And what's unique about this line is notice it doesn't have an x in it. So this is going to be a horizontal line through negative 4 on the y-axis. So I don't really have to do any points. It doesn't have any slope is 0. So I'm just going to draw that line right there. And I will be shading above that line. So all of this area up here, since it's greater than. I'll just do a few little pink lines so I see what's going on here. Okay, that's my pink line. Now let's do my blue line. I have y is less than or equal to, so again it's solid because it's or equal to, and it's a less than, so it's going to be below, negative 3x plus 2. So here's 2 on the y-axis, so my slope is negative 3, down 3 and right 1, or up 3 and left 1. And this line is solid, so let's connect those dots. And I want to shade below this line. So where's the y-axis below? It's going to be kind of to the left part of it. So that's going to be all of this over here, that whole area there. Now let's look closely and see where is the overlap of these two shaded regions. So since it's above the pink line and below the blue line, it's going to be this area right in here. So let's go ahead and make that plenty dark. You can do this in two different colors if you'd like. I just want it to be really clear to me where the overlap of the shading is. Just make that area nice and dark. So there's my solution. Any point in that area is true for both of those inequalities. And then let's take a look at our last example here. 3x minus y is greater than or equal to 2. And 3x minus y is less than negative 5. I'm going to rewrite each one of these in slope-intercept form to make it a little easier to graph. So for the first one, I'll subtract 3x from both sides. That gives me negative 3x plus, or negative y is greater than or equal to negative 3x plus 2. And I need to divide both sides by a negative 1 so that I get a positive y. And recall when we divide an inequality by a negative number, I flip the inequality sign. So my greater than or equal to has become a less than or equal to, and that's 3x minus 2. Okay, I'll make that my pink one. Okay, let's do the second one. I'll do that down here. And again, I'm solving it for y, so I'll subtract 3x on both sides. So negative y is less than negative 3x minus 5. And this one also, I need to divide everything by negative 1. And my less than sign becomes a greater than sign. So y is greater than 3x plus 5. And This will be my blue one. Okay, so let's go back to our pink equation here. So it's a less than or equal to, so it's solid, and it's going to be below. And let's go ahead and graph that. -2 is my y-intercept. My slope is 3, so up 3 and right 1, or down 3 and left 1. And I'll make it solid. And I need to shade below. So right here is where the y-axis is below the line. So all of this area in here is going to be shaded pink. Okay, let's do our blue line. Blue line is y is greater than or equal to, or sorry, greater than 3x plus 5. So since it's not an or equal to, this one's going to be dashed. And it's a greater than, so it's going to be above. My y-intercept is 5. And again, my slope is 3. Notice I'm going to have two parallel lines. So up 3 and right 1, or down 3 and left 1. And this is dashed, so let's throw some dashes in between those dots. And shaded above, right here is where the y-axis is above the line, so I shade all of this area over here. Okay, and now I step back and I look for the overlap. Well, this is kind of strange. It's above the line that's on top, and the shading is below the line that's on the bottom, so there is no overlap. So for this one, I actually do get to write something. There is no solution, because there is no overlap of the shaded areas, which means there is no ordered pair on the coordinate plane that will work in both of those inequalities. So in this section, we took a look at how to solve a system of inequalities by graphing. Draw one line, shaded or solid or dashed, shade one side. Draw the other line, solid or dashed, shade the correct side, and then identify where the shadings overlap each other and color that in real dark. And again, that means that any point in that region is true for both of the inequalities.